Hey there, it's Travis. I recently gave a talk at a software development and business firm named Valent Partners, and I wanted to share the presentation with you today because it's a good progress update on some of the things I've been working on in the past several weeks. I know that some of you follow me on this channel to understand what might be beyond UX, and I'm also trying to answer that question. And this YouTube video is me documenting that journey. So in this presentation, I take the next step in that journey and I launch two open source tools that I've built, both at the intersection of AI and UX. One is called frameSmith and the other is called Audio to Insight. So if that kind of thing interests you and maybe some of the technical details behind the software development, then I think that you will enjoy this presentation. So without further ado, let's get into it. To start out with, what do I mean by AI for the purpose of this talk? Well, we can level set with something we are all familiar with, which is ChatGPT. ChatGPT, thinking about its application architecture, it has a front-end user interface, and it also has a backend. And if we really simplify things, it has a database on the left that persists conversations between humans and the AI. And then it has the AI itself, which here I've labeled as LLM. And in this case, this stands for Large Language Model. This is the AI and the brains behind ChatGPT. So this LLM is what I mean by AI for the purposes of this talk. And specifically, I'm talking about OpenAI's AI, which is GPT 3.5 Turbo and GPT-4. So a large language model, it sounds fancy, but at its core, it's very simple how it works. It receives input text and it tries to complete that text. It tries to predict the next word in a sentence, and it continues to do so until it deems that that sentence or paragraph is complete. The specific thing about OpenAI's models is that they're trained to be conversational assistants. So if you give it a question, then it's going to try to give you an answer. And if you ask it an instruction like write a haiku, it will try to write a haiku for you. So this is ChatGPT, the application. Nothing new, nothing fancy here, except it has some limitations. It doesn't have access to our personal data and it doesn't have access to our enterprise data. And this is good. By default, we wouldn't want these models to have access to our private data. That would be a breach of data privacy. There would be security issues there. But there are going to be cases where you want an AI to be able to reason on your personal and enterprise data so that you can automate things and you can do work with an AI on that data. And this was how I came to, well, let me first say that everything I say beyond this point is how to get a ChatGPT-like intelligence to have an awareness or have access to your private data. So this is what led me to create the Lean Canvas Bot 3000. And let me just start by explaining what a Lean Canvas is very quickly for those who don't know. So a Lean Canvas is a really good 5-minute summary on what a startup or a company is all about. So there are sections like who are the users that use the product, what are the user problems, and how does the product solve those problems. These are the product sections of a Lean Canvas. Then there's the unique value proposition and unfair advantage, and these are how the company differentiates itself from others. And then finally, you have things like marketing channels, key metrics that they track, operating costs, and revenue streams. And this is what I would term the business and marketing operations of the company. So this is me giving presenting a Lean Canvas to a research team in the Web3 space. And you can see we filled in the sections in Figma. People are putting questions in on Figma or comments to modify the sections. And it's a really nice collaborative process. And a Lean Canvas is a good way to get on the same page with a design and research and development team. The problem with a Lean Canvas, though, is that as a researcher, it takes me at least 3 hours, sometimes up to 10 hours if I don't really know the product category very well, to create a Lean Canvas from scratch. And I was recently in a situation where I wanted to create a lean canvas for an entire VC's portfolio of over 600 companies. So this is over a year of full-time work, and it just wasn't going to be possible for me to do this. So what did I do? I built a tool that generates a lean canvas for you. And the basic premise of this tool is that the user goes out onto the internet and finds high quality information sources about a startup or company, and then passes it through an AI, and the AI generates a lean canvas. Simple enough. So the first step of this is to prepare your data. And so there were several sources that I found that were really good for A16Z startups. Every time A16Z invests in a company, they write a blog post about why they invested in the company. So there are things like, how does the company differentiate from its competitors? What is the product? How is the product finding product market fit? It's very good for filling out some of the sections of a lean canvas. Then I found a TechCrunch article that is more surface level, but explains that the Asimov, in this case study that we're using, a biotechnology startup, received some funding from A16Z, and it's just announcing that. And then Asimov has some blog posts on their website that go really in depth on their biotech. And finally, there are some YouTube videos where the founders are talking about Asimov. And these are like hour-long YouTube videos, and we can scrape the transcript of these and use them as part of our knowledge base. So the next step is to scrape this data from the internet, and this ends up as text objects in Python. So we have 10 sources here, so that is 10 text objects. And you could think of these 10 text objects as being really long text documents, too long to feed our AI just as it is. So the next step is to split these large text objects into smaller documents. These are LangChain documents. LangChain is a coding framework we're using, so it's a specific data type. But you can just think about these documents as smaller chunks of the overall text that we scraped. And finally, the last thing we do is create something called a vector store. So for each document, we embed it using an embedding model. And what this does is it converts the text into a number or a vector that is of length 1536. This sounds weird, and why would you want to do this? Well, an embedding model converts it into a vector, and this vector represents the meaning of the text that was embedded, the semantic meaning. So if we just think about embedding single words like cat, dog, and flower, cat and dog are going to have vectors whose distances are closer than that of cat and flower. Similarly, if we then embed the word lion, then lion is going to be closer to cat. We intuitively know that these things are more related than dog, for example, and then flower is going to be even further away from lion. So this is how these vector embeddings work. And again, we get a vector embedding for every single document that we have in our knowledge base. Now, the next step to generate a lean canvas is then to ask a question of this knowledge base that would summarize or fill in one of the sections of the lean canvases. So the first section is the user group. And so we say, who is Asimov intended for? And then what happens is we retrieve the 5 most semantically similar documents to this query. And these documents, we hope, have the answer to who is Asimov intended for, because then what we do is we combine the plain text documents and the query into a single prompt and then feed that to the AI. And the AI answers that question, that section of the lean canvas. So let's go a little bit deeper into how this retrieval works. We have a query, who is Asimov intended for, and we pass this through an embedding model, so we get a vector that represents the semantic meaning of that query. And then we compare that vector, and we compare the distance of that vector to every single document vector in our vector store. So what we're doing is we're finding the 5 closest documents to that query. So this might be how it looks in really simplified 2D vector space. This is just a really simple example, visual example here. But we have the query up here, and then we have 3 documents. And you can see the distance of these documents in vector space to the query. So who is Asimov intended for? Well, we have a document that says biomedical engineers have adopted Asimov, blah, blah, blah. That sounds like it could be potentially answer that question. And similarly, we have Asimov provides a tool set for scientists, ... That also looks like a highly relevant document to return in order to answer that question. And you can see that these two are close to the query relative to a document that is not really related to the question, which is Asimov was founded in 2017 by ... So this document vector is so far away that it probably wouldn't be returned in the top 5 results. So in this way, this is how we find these 5 most relevant documents, and then we pass them as plain text into the prompt, and then at the very end of the prompt, ask the AI the question, who is Asimov intended for? So it's kind of like an open book test in that we're giving the AI the answers in the prompt and then asking it the question. And then, of course, you repeat this for all the other sections of the lean canvas, but you're changing the query that you ask the AI. So why do users adopt Asimov? And then you retrieve the 5 most similar documents to this query, pass it into the prompt, and then the AI answers section 2 of the lean canvas, and so on and so on. And now we have a full lean canvas. This took 3 minutes for the AI to run, and using GPT 3.5 Turbo, costs about 2 cents per lean canvas. So I think this is cost effective, and it's much faster than what I can do as a researcher, which takes me at least several hours for a lean canvas. Okay, so now I'll quickly demo a UI that I built for this lean canvas bot. So first we click get started, and we're using a biotechnology startup called Asimov as the use case for this. And then in the left column here, I feed in some relevant and high quality information sources from blog posts and news articles. So we start with a post from A16Z about why they invested in Asimov. And then here are 5 blog posts from the Asimov website itself. And if you go to these, you'll see that these are very in-depth into the technology of Asimov. Oops, I think I already got that one. The last article is a TechCrunch article just announcing that A16 invested about $5 million into Asimov. And then finally, we have 3 YouTube videos of the founders talking about Asimov. So we'll use the YouTube API to scrape transcripts from these videos. First, we click next. This is going to take 30 seconds or so in order to scrape the transcripts from the internet and clean them. And this is an intermediate screen where I just want the user to check the scraped data. Sometimes the data doesn't scrape correctly from the internet. So this is just where the user would kind of scroll through here and make sure that most of the information that they were expecting is in here. So we have a text box for each document, and here's some YouTube videos down here. And now I click generate, and the bot is going through the process I just showed you. The AI is asking 9 questions of this knowledge base that we created from scraping the internet and filling in a section of the lean canvas for each one. This process takes several minutes. And now we have the results of the lean canvas. We've got a text box for every section right here, so you can read it on the internet, but obviously this is not really the best way to read a lean canvas, so I allow you to download it via CSV. And if you open it on a computer, on Mac, it'll open in Numbers, and Windows, it should open in Excel here. Let me pull this over. And I just want to show you the extent of the analysis. It really returns a lot of good detailed information. So every row is a section of the lean canvas, if you can see this. And let's zoom in a little bit. And so here's your lean canvas. So if you're interested in creating a similar web application that is based in this AI and LLM technology, then the tech stack I used to build this was using Clerk for authentication, The app logic or the web framework was Next.js. I used a hosted vector database. This is where the vector embeddings are stored, like I was describing earlier. A hosted vector database called Pinecone. LLM orchestration is with langchain.js. There's also a Python library as well. And if you built a product like this, this is where you'd be spending most of your time. So if you're interested in this kind of product, I recommend you check out LangChain. For text model, I'm accessing OpenAI's API, GPT 3.5 Turbo in this case, and then I deployed to a website or a service called fly.io. And I got this tech framework from an A16Z template. The A16Z infrastructure team put together a GitHub repo called Getting Started with AI, and it's a good way to fork this code and quickly get up and running on creating a web app like this. Or you could fork my code. This is the open source tool I was telling you about. This one is called frameSmith. I call it frameSmith to make it more general because it comes pre-configured to generate a lean canvas, as in the questions to generate a lean canvas are automatically put into this repository. But I allow you to go in and change those questions because this is open source code. And in that way, you can define whatever framework you want. So this is an open source repository, github.com/tmk1221/framesmith, and that should take you to this repo. And let me know if you have any questions on getting set up with this or are having trouble with installing anything. I'm going to make a subsequent video that is a bit of a deep dive on this repository if you're interested. So how to adapt this code base? I already talked about it a little bit. The first thing that you can think about doing is think about the different data sources that you have available to you. So I'm loading data in from the public web via URL, but there are many other different ways that you can load data in. And LangChain has over 100 different ways you can do this. You can load data in from Twitter, from your email, from Telegram, from AWS, Microsoft OneDrive, Google Drive, like any cloud provider. There are specific integrations for them. There's hundreds of ways to load data in. So just think creatively about what kind of data you want, and then also think about what framework you want to compress this information into. Again, frameSmith comes pre-configured for the lean canvas, but you can define any framework you want. And the way that you would do this is change the questions in the config.json file. What are the limitations of this? Well, first of all, it's not fully automated. It's close. It's better than I can do as a researcher, manually taking about 3 to 10 hours for me to do a lean canvas. But the lean canvas bot, if you add together the time it takes to find the sources and also run the bot, let's say that's 10 minutes per lean canvas. Where all this is headed is fully automated, where you can just type into a prompt, lean canvas Asimov, and an AI agent goes out and finds the high quality information sources it needs. It finds out how to scrape that data and then run the lean canvas bot that I've already shown. And you could think about really now you could automate 1,000 startups like this, and it would take like 0.1 second per startup, because it's just, especially if everything can compute in parallel on the back end. The next thing I want to talk about is document splitting trade-offs. This is a bit of a technical topic to get into now, but if the performance is suffering in frameSmith, document splitting length is the first place I would go to optimize your performance. So this is a full text object in Python right here. It's a full article that we scraped from the A16Z blog post. And right now I'm splitting it into 1,000 character chunks. And these get turned into documents, which get turned into vectors. And these vectors represent the semantic meaning of these text documents. Okay, that's just review. Now you can think about increasing the size of the document, and this provides more context to your AI, because remember, these documents are getting fed into the prompt. So a larger document is going to give more context to the AI, which is a good thing. The bad thing, though, is that the extra text in the document is going to dilute the semantic meaning of that document. And so it's going to be more difficult to return relevant documents because you are essentially diluting the vector embeddings or the semantic meaning of the vector embeddings when you create a larger document. You could think about going the other way and create a smaller document that gives you really specific vector embeddings, so it's easier to return relevant documents to the question you're asking. But the smaller documents provide less context to the AI, and I think you'll find if you create too small of documents that you're going to be cutting off the answer in the middle of a document, and your AI won't get the full context for the answer it needs to give. There's a best of both worlds approach called parent retrieval, where you split smaller documents, but you return the entire parent document. So if my AI thinks that this is the relevant child document, it's still going to return this entire parent document into the prompt. So that's one workaround. And finally, the last limitation of frameSmith and the Lean Canvas bot is that the answer to your framework question is just not present in the vector store. I'm skeptical that you can find all the information that you would need to create a Lean Canvas on the public web. The information that I loaded in did a good job at answering most of the sections of the Lean Canvas, but some of the sections the AI has to make an informed guess. And this is actually another best of both worlds scenario that the AI handles. I implemented this so that the AI will never explicitly lie to you. It will always tell you that whether or not it has the information needed to answer the question. If it doesn't have the information needed to answer the question, then the AI will tell you that it's providing you plausible answers based on what it already knows about the startup. So this happens a lot with the operating cost section of a Lean Canvas. The startups are just not going to be transparent on the public web about how much they're spending and what they're spending it on to operate their business. So what the AI does is it tells you it's providing its plausible operating costs for a synthetic biology company like Asimov. This is great because it produces an entire Lean Canvas for you, and it tells you when it doesn't know the answer to things. This is a best of both worlds approach, in my opinion. The next tool I built is called Audio to Insight. As you all know, I was a UX researcher for 7 years, and I found that the number one tool I wanted was a tool that could both transcribe audio of user interviews and then get that into a semi-structured format before I start doing the analysis. This would save me a time-consuming data processing step. So to explain further for those who maybe aren't familiar with UX research, what we do is we run one-on-one interviews with users, and we ask them to use a product in front of us or to understand their work scenarios. And we record these interviews, and oftentimes I'll end with 5 to 10 hours of totally raw, unstructured audio data. And within that data is presumably the answers to the research questions that I had, but there's a big gap and chasm between the raw audio and getting that into a final report. So what I found I wanted was to be able to pass these audio files through an AI that gets the interview data into a structured format where every user response to every question is summarized, and it's in this tabular format. And I'm not saying that you would send this to the client or that this would be a final deliverable to your research team. This would just be a very good starting point to conduct your qualitative analyses. So the first way that Audio to Insight works, the first step, is it transcribes your audio file into a text transcript. And this uses an open source library called WhisperX, which is really nice. It timestamps and speaker labels the text transcript. It's a very good tool for the first step. Then what we do, it's very similar to how frameSmith works. We ask the first question of our discussion guide to the first transcript that gets transcribed. And the AI will summarize user A's response to question 1. Of course, we do this for the rest of the transcript. In this case, let's say we have 5 questions. And we do this for all the other users. So you can see how each question of the discussion guide gets asked to each transcript from the user interview data collection phase. I also implemented a chat feature where you can ask specific follow-up questions of specific transcripts, and it prints the answer directly to your console. So it creates this ChatGPT-like experience, but with an awareness of your transcript data. So this is Audio to Insight. Again, it's an open source tool, and I built it for UX researchers, market researchers, ethnographers, anyone who's conducting qualitative data analyses. And this is meant to amplify you. It's not meant to take your job. As you can see, there's still going to be a lot of steps that are needed from the human afterwards. It just eliminates that mundane data processing step between raw audio transcript and the initial user responses to each of your questions. So what is the future outlook of all of this? Well, I think that it's really interesting to think about, what do you do after the AI has given you this output? So it automates analysis. So now we have this concise, structured data for our interviews, and we can ask this questions. So we can say, compare question 4, which is compare the landscaping process for all users. Like, look at all of the user responses across question 4, and then create a PowerPoint slide about their similarities and differences. So this would automate reporting. And this is a linguistic user interface, LUI. A linguistic user interface, just think of it like ChatGPT. It's just a conversational AI. But I think we're headed more and more to these LUIs, and I would expect in the next 5 or 10 years for the UX researcher or any qualitative researcher to be using linguistic user interfaces more and more in their workflows. So if we think about the evolution of user interfaces from the initial computers, you had to understand specific context. You basically had to know programming languages and interact with the computer on the command line interface in order to use a computer. Then, as we all know, Apple came along and created the graphical user interface, which democratized computer usage to almost everybody on Earth. And this is why we are all in the great profession of UX. We're very proud of the ability to create simple user interfaces for people to use. I think, again, more and more, a more intuitive interface, and I know this is a subsect of graphical user interface, is a linguistic user interface, because I think telling a computer what you want with natural language is more intuitive than understanding the symbols to click on a GUI. So what are my next steps in all this? I'm going to track the big players and what they're doing with linguistic user interfaces. There are already consumer products available from big players like Google that are doing similar things to what I've showed you in this presentation. So for example, Google Bard, this is Google's AI, has recently integrated with Google Workspace. And what this means is that the AI now has access to the documents that you have saved on the Google Cloud. So I have a Google Doc called AI x UX presentation, and I just asked the AI, summarize this document for me. So again, the AI can read this data and then summarize it for me. I will tell you, I did try uploading a transcript, an interview transcript, into my Google Drive, and then having the Bard, asking Bard specific questions about this transcript, and it didn't perform as well as my Audio to Insight bot. So this tells me that it's probably an issue on the back end with how the documents are being split, and for a specific use case like a UX research assistant, maybe a bespoke product like mine will always be better than a general product like Google Bard Workspace. Also, ChatGPT Plus now has a web browsing feature. So we all know that the models are trained only up into a certain point. So GPT 3.5 Turbo only has an awareness of data up into, I believe it's September 2021. So if you ask ChatGPT what is Valent Partners without this browsing feature, it won't know because it's not stored in its native memory. This is a company that was recently founded. But if you ask it in its browsing mode, then ChatGPT Plus goes out onto the internet, searches Google for Valent Partners, and then finds Valent Partner website and returns information about it, and then answers your question based on the website information. Finally, there's a company called Otter AI. They've been around for a while transcribing virtual meetings. You've been able to invite a Otter bot into your Google Meetings or Zoom, and it transcribes the entire meeting for you. But now Otter has introduced a chat feature where you can now start asking questions of your meeting transcript. So I had a meeting with my dad about how AI could be used in market research, and it was about an hour-long meeting, maybe 30 minutes, and I asked it at the end, I said, what is Travis's action item for this meeting? And it told me exactly what my dad and I had agreed on I would do after we had met. So this is how chat is being used now. Chat interfaces is being used now in consumer products. Thank you all so much for watching. I hope this gave you a good understanding about what led me up to the AI tools that I'm building, and I hope this kind of unveiled the two tools that I'm working on and I open sourced recently, which is frameSmith and Audio to Insight. Have a good day, everyone.